Hi, dear students, how are you? I hope you're fine. Today we are going to have lesson 1 on week 2, grade 8. So I have here simplifying algebraic expression. How can I do it? It's very simple. Remember first, if I have a ratio like 2 to 3, it means that it's the same as 2 over 3 fraction, and also 2 divided 3. So it's the same as here 2 divided 3. This fraction is called what? Division. So we have here 3 kinds, 2 divided 3, 2 to 3, and 2/3. All the same meaning? Yes, all the same meaning. So I have here what? If I have here this question, he asks me write 8 over 12 or 8/12 in the simplest form. So it's very easy to make it like this. Divide both, simplify means divided. So divide both sides by, divide both here numbers by what? The denominator and the numerator. This is the denominator and this is the numerator. By what? By a common factor. Which common factor? The greatest common factor. Why the greatest common factor? To get the simplest form. So 8 and 12, how can I get the greatest common factor, guys? 8 prime factorization, 8 equals divided 2 gives me 4, divided 2 gives me 2 equal 1, right? We have here 8 divided 2, 4, 4 divided 2, 2, 2 divided 2, 1. So the factors are 2, 2, and 2. And what about here the 12? 12 here divided 2, 6 divided 2, 3, divided 3, 1. 2, 2, and 3. So we have 2, 2, and 2, and the other one 2, 2, and 3. How can I get the greatest common factor? Only the here repeated ones. 2 multiply 2, and this is not repeated, this is not repeated, so the greatest common factor is 4. So guys, I will here divide both sides by, yes, by 4. Divided by 4, divided by 4. 8 divided by 4, 2. 12 divided by 4, 3. So it would be 2 over 3. Miss Dina, we can do it by another way. Yes, of course. 8 over 12. We can first of all multiply, divided by 2. It gives you here, and divided by 2 gives me 4. 4 divided by 6 divided by 2 also divided by 2 gives me 2, gives me 3. So the answer will be 2/3. Okay, it's easy one, easy one. We have taken this before. What about now if we have here algebraic expression? 15a and b to the second power over 20a to the second power b. How can I solve this? Divide the numerator and the denominator by what? What's the common here between 20 and 50? Common is 5. Yes, common is 5. And we have another common. Yes, we have. We have taken this the last lesson. We have here a power 2 and just a. So we will take just a. B to the second power or b just b. So divide both here the numerator, the up, and the denominator by 5ab. So it would be what, guys? Let's see this. 15 divided 5 gives me 3. A divided a gives me 1. B to the second power divided b to the first power, it gives you just b, right? Over. We have here 20. 20 divided here 5 gives me 4. A to the second power divided a gives me a. B divided b gives me 1. So the answer will be, after simplifying, 3b over 4a. Remember, guys, a very important hint that I told you before. When I say b to the second power, okay, divided b, what should I do? I take b, the base here, and 2 minus 1. It gives me just b to the first power. It means b. Remember this well, okay? Okay, what about here, this one? It's easy? Yes, I think it's easy, guys. Let's do this 6x here over 15x to the second power. 6 and 15. Both in table what? 3. So divided by 3. Divide both by 3. Okay, I have here x, and I'm getting here the greatest common factor, if you notice that. 3 x and x to the second power. What should I choose? Just x. So the greatest common factor here is 3x. 6 divided 3 gives me 2. X divided X gives me 1. And what about here, the denominator? 15 divided 3 gives me 5. X to the second power divided X gives me just X. So here's the simplest form, 2 over 5X. 2 over 5X. Easy one? I think it is. Okay, guys. This is some examples. I want you to read them and answer them as homework, please. And it would be very easy. So I have here and the end answer here to help you if you are doing right or wrong. Also, I'm going to correct them all. Okay, guys, let's see here lesson of multiplying and dividing monomials. Here, guys, as you see, monomials here we have talking about the monomials before, and it would be very easy for you today when we answer them. To divide here, as you see, this is the rule. This box also is the rule of every here lesson. So to find the product of powers that have the same base, add their exponent. As I told you, if I have here a to the am and an, it would be am plus n. For example, if I have here, I need the marker. If I have here, just a moment, guys. If I have here 3 to the second power multiply 3 to the fifth power, so it would be 3 to the 2 plus 5 here, so it would be here what, 3 to the seventh power. Remember, we have taken this last week. And the other one I have got here, if I say 2 to the fifth power multiply 2 to the third power, so it would be 2, 5 plus 3, so it would be 2 to the eighth power, right? Okay, what about here b to the eighth power over b to the second power? It would be b8 minus 2, so it would be b to the sixth power, Okay, here some practice in this. I have here find each product or quotient. Express your answer in exponential form. Exponential for exponents, I mean power. M to the fourth power multiply m to the third power, so it would be m 4 plus 3, 7. It's easy like this, yes. Okay, guys, I have here what else? I have here this one. Let's see, 15 to the seventh power over 15 to the second power, so it would be 15, 7 minus 2, so it would be 15 to the 15th power. Okay, guys. Okay, this one is also a good one. Find the missing exponent. Y to what power multiply y to fourth power gives me y to the 10th power. What do you think? 10 here is the product, so 10 equal 4 plus what? 4 plus 6, so the answer here is 6. What about this one? Very easy one also. I have here 20 to the 15th power over 20 to what power equal 20 to the 5th power. Here this 15 minus what gives me 5. 15 minus, yes, minus 10, so the answer is 10. Easy one? I think so. If I say here for this one 8 to x again, x to 8th power multiply x to 7th power, okay, divided x to the 3 power. So I will solve this first. It would be x times, so x 8 plus 7 equals, yeah, we have here 8 plus 7, 15 here, 15 here, also this is what divide, so divide, I will make the 15 that I got from 8 plus 7 minus what, minus 3, so it will be here 12, so the answer will be x to the 12th power. Okay, guys, let's see this one. The word problem, it's important. The Italian mathematics Pietro Cataldi, born in 1548, wrote exponents differently from the way that are written today. For example, he wrote 4 here, 5 for 5x to the second power, and 5, can you see this sign? For 5x to the third power. How do you think he would have written the answer of, let's see, the answer of 6x to the third power times x to the fourth power. I have here 6x to the third power multiply x to the fourth power. So guys, it would be here 6, and here he write for any x to the second or to the third, he write here as you see here, here for 3 to the third power he write 3 and write like this. X to the second power he write 2 and write this. So here 6 would be 6 to what? 6 here to the, we have 4 and 3. 4 plus 3 equals 7. So he will write it as 6, 7 and like this. Okay, this is like x to the power 7. Okay. The rest are homework. The rest of the exercise is homework, inshallah. If you have any problem, please send me. Now we are going to have lesson negative exponents. What does a negative exponent mean? Look at some examples. We have here 2 to the negative 2 sign, as you see. So it's like what? We convert it here as fraction, like this 1 to the second power, 2 here to the second power, 1 over 2 to the second power. And this means what? 2 times, here 2 is repeated 2 times, it means quarter. What about 3 negative 4? Instead of here we have negative, so it's very easy to make it like this. Okay, reciprocal, and do 3 times. Here 3 is repeated 4 times. 3 times 3 times 3 times 3. This means 81. Let's see how can we use for a non-zero number a and an integer n. As you see, this is the rule, guys. This is the rules. If you have a to the power negative n, I here make them upside down, 1 over a n. Okay, guys, let's see some examples and solve them easily. We have here 2 to the negative 3 power. So I will do it as this 1, okay, over 2 to the third power. Okay, guys, it's easy as this. And here, right here, he gives me a question, right? 1 3 over 3 to the second power as an expression using negative exponent. So it would be 3 to the negative 2 power. Okay, I have here another one. Let's see together. This is the practice, okay, how to practice this. X to the negative 5, y to the negative 8. So how can I solve? So this one, I want to write it. 1, we have here negative negative. So 1 over x power 5, y power 8. This is the simplest form, yeah, because different here, unlike terms. N number 4, n negative 7, it would be 1 over n 7. Okay, guys, for this one, pq negative 2, so it will be 1 over pq2. Okay, easy. Okay. And I have here this one, number 11, this one, 1 over t negative 7. So the opposite of it will be t7, the opposite, okay? Okay, let's have here this one. He asks me here to evaluate each expression. This one, evaluate each expression when n gives me equal negative 2. So we have here 3n. Instead of n, what should I write? Negative 2. So this can be 1 over 3 to the second power, 1 over 3 times 3, 9, like this. Easy and interesting. This one, we have here this one, n to the negative 4th power. So instead of n, I write negative 2. And I have here negative 4 up, negative 4. So the opposite will be 1 over 2. Okay, 1 over 2. 1 over negative 2, don't forget to write the negative 2, and here this exponent will be 4. 1 over negative 2 here to the 4th power. Remember, guys, when we have negative and power like this, negative, it gives me always positive, and this is even. This is the power here is even, so it gives you what? It gives you here even result. So negative even means gives you, positive, negative, multiply negative, positive, multiply negative, negative, multiply negative, positive. So the even gives you positive sign. So it will be, okay, 2 to the fourth power, 2 times 2, 4, 4 times 2, 4 times 2, 8, 8 times 2, 16. Okay, guys, easy one now. And we have here this example. It's important to express a to the third power, b negative 4 power, c 2 to the second power, d negative 1 power. So he wants me to use positive exponents, so the positive here, a to the third power. B is down, okay, b is down. When I convert it into down, so it will be positive. C here already positive, up. D negative 1, so will be d down positive 1, or just d. So it will be the, okay, the fourth here, fourth choice is the right choice. Guys, let's go to the next here lesson. It's scientific notation. How can I solve this? We can use the scientific notation, guys. It's important to have a hint about the scientific notation to write very large or very small numbers. Numbers expressed in scientific notation are written as the product of factor and the power. Okay, as a factor and a power of 10. Of course, it must be power of what? Power of 10. The factor must be greater than or equal to 1 and less than 10. What are you saying, Miss? Let's see this by examples. Okay, we have here this example. Write each number in a scientific notation form. So I have here, as you see, I want the marker. I have here 93, okay, million. So how can I write this in scientific notation? This is the rule, guys. How can we solve it? Move the decimal point 7 spaces to the left. Why? Because I want something point decimal. I want it as a decimal. So I have here how many zeros, guys? 1, 2, 3, 4, 5, 6, and I will take just 1 for the decimal. So I want to move it to be 9.3, and I move it how many decimal places? 7 decimal places. So I will put here how many zeros? 7 zeros. When I say 7 zeros, 1, 2, 3, 4, 5, 6, and 7, it means that 9.3, 10 to the what power? 7 zeros means to the power 7. So the answer will be 9.3 to the power 7. Guys, this is the explanation why. Multiply by a factor of 10, which in case of 10 to the 7th power, because you moved the decimal point 7 spaces to the left, as I told you. What about this number? Let's see together. I have already here a decimal. So I want to here move the decimal point what? How many decimal places? Let's count the zeros together. 1 after the decimal point, of course. 2, 3, 4. 4 decimal places, yeah. And another one, I want to put it here. I want to put it why here, guys? Because it's very small number. And I told you before, I'm using this for very large numbers and very small numbers. So I will move it how many decimal places? The 4 zeros plus 1 number. So it will be 5 decimal places. Move the decimal point 5 spaces to the, this time to the right, and it would be 6.22. This time times 10, I moved it 5 spaces, but to the right, So negative, the power will be with the negative 5. Okay, negative 5. Let's see another example here. He asks me here about what? To write 8.3 multiply 10 to the negative 4 in standard form. Oh my God, standard form? Yeah. So 8.3 multiply what? Multiply. So I have here 8.3 multiply 10 to the negative 4. So 8.3 multiply 10 over, yes, 1 over 10 to the power 4. Again, please. So it's 8.3 multiply 1 over 10. Here to what? All to the power what? All to the power 4. I can write it here or write it outside here. Okay, guys, I can write it outside as you see. So why? Because here it would be what? The same result. 8.3 multiply 1 over, okay, 4, okay, here to the 1 to the 4th power, 1 times 1 times 1 times 1. Here I have 4 to the 10th power, so 10 times 10 times 10 times 10 times 10. So it would be 1 over 10,000. Can you see this? Okay, guys, it's easy. Okay, so 1 over 10,000, as you see, is 0.001 or 0. And if I multiply them, it will give me here 0.0083. Okay, guys, move the decimal place 8.3 4 places to the left. Okay, and I will let you keep it like this if it's easier for you. So I have here some questions to make sure that we understand, guys. Okay, he asks me here to write each number in scientific notation, as you see. So for the first one, I have here 3,265,000. Okay, guys, I want to put here a decimal point where after 3.265. So 3 point, I won't write it in a very good so it will be 3.265. How many decimal places I moved? 1, 2, 3, 4, 5. So I have here 1. I want to count with you again. 1, 2, 3, 4, 5, 6. Again, guys. 1, 2, 3, 4, 5, 6, and I put here the dot, so it will be 3.265 multiplied by 10 to what here power, to the power 6, to the power 6, to the 6th power. Okay, okay, now we have this one. 0.0057. I want to make it scientific notation. This time we have decimal, so we are going to move from left to right. 1, 2, 3, 4, and put the decimal point here between 5 and 7. So 5.7 multiply 10 to the let's count 1, 2, 3, 4 to the -4 power, to the -4 power. Okay, guys, the rest of the exercise is homework. I hope you understood everything. If you have any question, please send me on Google Classroom. Thank you.